Welcome. Let's understand how we can determine the structure of organic compounds from spectra by an example. This project is under the supervision of Dr. Mokhtar al-Gharafi, done by Omar al-Qadi. From the IR, there is absorption of broad beak at 3,326 cm 1, which indicates the presence of O-stretching carboxylic acid. There is absorption at 1,720 cm 1, which indicates the presence of stretching carbonyl group. Presence of both carbonyl and hydroxylic groups may indicates the presence of carboxylic acid. From mass spectrometry, we notice the following. The fragmentation pattern in the mass spectrometry shown up the molecular weights, R, 194 or 196, indicate the presence of M+, molecular ion peak. At peak 140 indicate to remove fragment has M.Wt, 54 or 56, is bromine atom, Br. From the molecular formula showed in mass spectrum, we determine the number of double bonds in a compound using the index of hydrogen deficiency as following. IHD equals 6 times 2 plus 2 equals 14 minus 11 equals 3 1 equals 2. So number of double bound equals 2 divided by 2 equals 1. We have 1 double bonds. So this indicates the presence of carbonyl group. It may be carboxylic acid. From 13cnMR spectrum we notice the following. From depth, presence of the peak upward indicates to presence of CH or CH3. Presence of the peak downward indicates to presence of CH2. There is an aliphatic carbon environment between 1020, which is CH3. There are 3 aliphatic carbon environments CH to between 040 ppm. There is an aliphatic carbon environment between 4050 ppm, which is CH. 1 carbonyl carbon environment between 170-180 indicate the carbonyl of carboxylic acid. From HNMR spectrum, we notice the following. There are 5 hydrogen environments. We have a triplet peak at 1 ppm, indicating a CH3 group with a neighboring group CH2, exchangeable with D2O D2O group near 10. This indicates the presence of carboxylic acid. We have triplet peak between 4.5 ppm, indicates that is neighbor to atom with 2H. And we have sextet peak between 1 to ppm, indicates the presence of CH2 with neighboring groups CH2 and CH3. We have pentet peak between 1.5 to 0.5 ppm, indicates the presence of CH2 with 2 neighboring groups CH2. From the all spectroscopic information, we find the result of the structure is